All right, so there's lots of different types of factoring. The first one and probably the most common one is just called pulling out a greatest common factor. All right, do you guys remember what a greatest common factor is? What is it? What do you think it is?
It's the...
No, you're fine.
To get the number.
Right, so like, yeah, so like the biggest thing that you can like divide by, pretty much, right? So let's say we have, thank you. There it is. So let's say we have 3r plus 6. What would the greatest common factor between 3r and 6 be? 3, right? So that means we're taking 3 out. And so then we divide each piece by 3. So what's 3r divided by 3? R. Right? And then 6 divided by 3 is 2, right? So it looks like that. We're like undoing the distributive property. Okay?
We did this.
Okay, I figured you guys probably did this part. Some of the other stuff might be a little different, but right, so like if I were to multiply it back together, I should get what I started with.
What do we use there?
So later on, we'll have to like simplify stuff. So like if we were to simplify like a fraction, like you would have to cancel like individual pieces like r plus 2 out. You can't just get rid of r or 2. Like, so sometimes we have to break stuff down because it's good for the simplifying process. And then also as we move on to solving quadratic equations, so that's equations that have like x squared and x in them, you have to, factoring is one of the ways we can solve them. And you use it a lot through like pre-calculus and calculus, and it's just a good skill to have. Okay. All right, so let's practice another one. So let's say we have 12x to the third minus 24x squared. So, yes, 12x squared. Does everybody see how we came up with that?
Where'd you get this? Oh, never mind. I got it.
Because this is x cubed, this is x squared. So typically it's going to be whatever your like smallest exponent is. Okay? Right? Because we can divide both of these by 12x squared and have some stuff left. It's the biggest thing we can divide by. Right? So especially with the exponents, if you're not sure, it's usually going to be the smallest one that any piece has. Because you can't take out more than what's there. So, all right, so then when we divide 12x cubed by 12x squared, what do we get? X. And then 24 divided by 12 is 2, and then the x squareds cancel out. So it's just x minus 2. All right.
How did you get the x? Is it just because you divided the x?
Yeah, so 12x cubed divided by 12x squared. So 3 minus 2 leaves you with a 1x. Like, because you're dividing each of these by 12x squared to get what's in here.
Oh,
Okay?
okay.
Okay. So we feel good about that?
Yeah.
Yes? Huh?
That was not me.
Oh, do you have a question?
No.
Oh, I thought that's what...
That was a confirmation that I'm good.
Oh, okay.
You're being silly.
Okay. Good deal. All right. So then let's talk about, so this is called removing the greatest common factor, if you need to know that. Okay. All right, can I go on to the next slide? Claire, quit drawing on my plant.
It's pencil. It can wipe off.
Still, it means I have to wipe it off. All right.
I'll wipe it off.
Thank you. Okay. So then the next one is called factoring a difference of two squares. right? Or difference of squares is just the fastest way to say it. So this is one of those that only works for certain things. Okay, so in order to use this one, you have to be able to evenly take the square root of both terms. So let's say we're trying to factor 16x squared minus 81. Okay, so is there a common factor we could pull out of these? No, right? But we can still factor it. Can we take the square root evenly of each of these pieces? Yes. Right? So we're like undoing a special FOIL, basically. Okay? So what's the square root of 16?
4.
Right? And square root of x squared would just be x, right? Because 4x times 4x is 16x squared, right? Okay, what's the square root of 81?
Oh, wait, no.
Huh?
Nothing.
Okay. And then one's a plus, one's a minus. Right? They're conjugates. Right? Remember when we multiplied them together and it dropped that middle?
Is the first one always plus?
It doesn't matter. You can do minus and then plus, as long as you have one of each. It does not matter what order you put them in.
So why did we have to do the 4x? Why couldn't we just have 4x plus 9? Why did we have to have
Because
minus as well?
when we multiply this back together, if we FOIL it back, we want to get this.
Okay. And how will we know when to do this? Because you said there's like specific.
So you have to these will only have like an x squared and a number, or like x to the fourth and x squared. So it's only two terms, okay, even exponent, and you have to make sure you can take the square root of both pieces individually. Okay? So that's how you know. Okay, so then let's look at this one. Let me do a different color. Ocean, what's your favorite color today? Okay. So, we only have two terms, right? Can we take the square root of these?
No.
Okay. Do they have a greatest common factor we can pull out?
Yes.
Yes. What is it?
25.
You're thinking backwards. You already divided. What did you divide by to get 25?
3.
3,
Yeah.
right? Yeah, you can't take 25 from 3.
Yeah.
Right, no, he was just, I got it. You were a step ahead.
So would it be 3x squared?
So 3, right? We're dividing both pieces by 3, which leaves us with x squared minus 25, as Christian told us, right? Y squared. Can we take the square root now? Yes. Right? So do you just leave the 3 outside? Okay?
Why are we doing this? I thought.
Because right now we can't take the square root of these. So if you can't, the next step, really your first step should always be, can I take out a greatest common factor? Okay? And then you want to look for other methods. Because if you always pull out a greatest common factor, you're going to have easier numbers to work with.
So what are we trying to do?
We're factoring. We're breaking it down into all of its pieces. We are undoing all of the multiplication that's happening.
So
What
we
else
just
can we do?
So we can do our difference of squares now.
so we're just trying to break it down as much as we can.
Exactly.
Okay, because I thought for some reason.
Yeah, we're breaking down. So the now difference of squares. So the square root of x squared is just x. Square root of 25y squared would be 5y. And then one's a plus and one's a minus.
In any circumstance, we're not going to be able to break it down farther than that, are we?
I've never, the word, things like will never or like it's always like this don't ever really apply to math. But for the most part, this is as far as you can break it down right now. Okay. Okay, so what about, let's do another one. This was a minus, this was a minus. That's another one of those, like, you can only use it in certain situations. So have to be square roots, have to be subtracted. Okay? What about this?
4.
So you just
Square root 4.
What?
Yeah, to the 4th.
It is to the fourth already.
Exactly.
So,
Just take it away. Like, divided by the...
like x squared and then do it again.
yes. Okay, yes. So, like when you take the square root of that, you're like dividing it in half. So you get x squared and y squared and y squared. Is that what you meant?
No,
Oh, okay.
not personally.
Then you would do a split to 4.
Not, well, you can't split 4. Oh, it also always has to be a minus sign in between them. Because it's called a difference of squares. So, like, we can factor this one further. We stop here. Yes, Joanna.
Does it matter, like, which one is the subtraction, which
Nope.
one is the plus?
As long as you got one of each. I switched it up this time just to show that it doesn't matter. Okay, so since this one, we can take the square root of those, and it's a subtraction, we can keep going.
Yeah.
We can?
We can. So we're looking at this piece here. So what's the square root of x squared? X. Square root of y? Y. Okay, and then this other guy just hops on down here. What?
Wait, why did we bring that down?
Oh,
Because we would have to multiply all three pieces. Stuff can't just disappear.
That's what I was thinking when you were doing it.
Yeah, like it can't just disappear. Like if I were to multiply back just these two pieces, that wouldn't give me what I started with. So like we're pulling stuff out, but it doesn't just go away.
Okay. So then does that mean we could do this further by doing the x squared plus y squared?
No, because it has to be a minus sign in order to keep going. Like it's called a different, like notice how how are we feeling?
Good.
Not bad? Okay.
I also said that before.
But like I feel like I'm gonna go to do it and then I'm not gonna.
Well, we're going to go ahead and do some.
Oh no.
Why?
I'm scared.
Why?
I don't know. It just goes.
I mean, like, and there's lots of other stuff in this section, but I like to teach regular like, it's just like, it's fancy ways and shortcuts, which I think are fine, but I like if you don't have the regular factoring down, this other stuff isn't going to make sense. So we're just doing this little part of 1.4.
Can I ask you a personal question?
Sure.
Not personal. Do you have any siblings?
Yes, I have one sister. Her name is Claire. Yes, she's older. Yes. I have a Claire, yes. She's up here somewhere. Where is she? That's her. With the baby. Above the R.
Okay. Thank you.
You're welcome. Okay, so on page 28, I want you guys to try 1 through 12 and 31 through 38. So 1 through 12 is just the GCF stuff.
I
And
can do that.
31 to 38 is the difference of squares.
She draws her age like this.
Hey, I used to do that. I still do sometimes.
Like what?
Like snowman.
Looks like a snowman.
Yeah, snowman.
Oh yeah.
It just depends on what mood I'm in. I've done both.
It looks better. Yeah.
All right, so like 9 through 12, they look like, huh? Did you say too late? No, ma'am. It's never too late for math. There's always time.
I'm not gonna be taller about this. You're always
All right, children.
What is this called?
This is still just removing a greatest common factor. Right, so what do they have in common in each part?
M2.
M what?
M and 2.
M plus 2,
Oh,
not M2.
sorry.
There's a plus sign there. Right, so that, yes, there is.
I was going to English where it's
like, I'm just like M2, instead of saying like,
Oh, yeah.
oh, what's the subject? Instead of saying Billy and Bob, you just say Billy Bob. Because you can't say and, because and's not a part of the subject.
All right.
I didn't know the plus sign was like counted.
I relate
Oh,
to you.
yes. So if it's in parentheses, the whole thing matters. It's all important. So that means m plus 2 is our greatest common factor. So we're removing the m plus 2.
That's not.
And then what are we left with?
The 12x and the -5.
12x minus.
Yeah, that's all.
Awesome. Thanks, bro.
Awesome sauce.
Okay, so that's what you use on 9 through 12.
Thank you.
You are welcome. The end.